In section 1.6 part 2, we'll be solving inequalities with absolute values in them. So how does the process change if you have an inequality? Well, it doesn't change too much. You just need to remember equation 1 is identical. Equation 1, same as original. You're just dropping those bars. Okay, so the process is the same. It's that second statement's going to change a little bit. You need to remember to inverse or flip the inequality and change the sign on the right. So the first inequality statement is identical to the original. You just drop the bars. The second inequality statement, you need to flip the inequality symbol and then change the sign on the right. So it's got a little twist, and that's because when you're changing the sign on the right, you're essentially multiplying by that negative number, which flips the inequality. So let's go ahead and try one. The directions ask us to solve the inequality, graph it, and then write the answer using interval notation. Very important. Make sure you're using your interval notation. We'll start off with a gentle example, example 6, which says the absolute value of 3t minus 2 is less than or equal to 7. So the first statement is 3t minus 2 less than or equal to 7. Nothing changed. We just dropped those absolute value bars. The second statement is going to be the absolute value. I'm sorry, it's going to be the 3t minus 2. We're dropping the absolute value. But now instead of less than, we're going to use a greater than or equal to, and we'll make it a negative 7. So we flip the inequality and change the sign on the right. Then we'll solve both of them. So 3t is going to be less than or equal to 9. T is less than or equal to 3. That worked out nicely. Over here, we're going to get 3t is greater than or equal to a negative 5. So t is greater than or equal to a negative 5 thirds. So not as nicely on that one. But now we need to interpret that answer. So what does that answer really mean? So I'm going to go to the number line to do that. Whatever you do, make sure you get them in numerical order. So negative 5 thirds is the smaller number. It's going to go on the left side. The positive 3 is a larger number. It's going to go on the right side. Both of them have the equal to on it. So we're going to use solid circles. And then we're looking for numbers that are less than 3. Well, that would be to the left of 3. We're looking for numbers that are greater than the negative 5 thirds. This is going to be to the right of the 5 thirds. So we're trapped between those two statements again. So we're going from negative 5 thirds to 3. So then my answer would be with a bracket, negative 5 thirds, and then ending at 3 with a bracket. And that's our answer. Nicely done. So that was a less than. Let's go do a greater than as an example and see how that works. This is example 7. Example 7 says we have the absolute value of x plus 4 plus 3 is greater than 5. We have that extra term again. Make sure you take care of that before you write your inequality statements. So this is the absolute value of x plus 4 is greater than 2. So my first statement is going to be x plus 4 is greater than 2. Our second statement would be x plus 4 is less than a negative 2. Moving the forward is going to get x is greater than negative 2 over here. And moving the 4, we'll get x is less than a negative 6 from that one. Pretty simple solving on that one. But we need to interpret what's happening here. So we're going to go between, here's the negative 6, here's the 2. This time we'll use open circles. Okay, this inequality statement, make sure I get it right, is saying that x is greater than a negative 2. Well, all numbers that are larger than negative 2 are to the right, not to the left, to the right. This statement is saying we need all numbers that are smaller than negative 6, which would be to the left. So the picture looks much different than it did last time. Last time they were pointing towards each other. This time they're pointing away from each other. That's okay. It simply means when we go to write our answer using interval notation, we need an interval that matches each one of those. For the left picture, we would be going from negative infinity to negative 6 with the parenthesis. For the right graph picture, we're going to start at negative 2 and go off towards infinity. Parentheses everywhere because they're exclusive. You're excluding those endpoints. And then finally, you need a symbol between the two, and the mathematical symbol we use is a U, which stands for the union of the two sets. It means the answer is everything in both sets. And there's your answer. So when you're solving these, they're either both going to point towards each other or they both point away from each other. They will never, ever point in the same direction. So make sure that if they do, it means you've made a mistake. You can go back and catch that mistake. So that was example 7. Let's take a look at example 8. So example 8. We have the absolute value of 2x minus 1 is less than 2. Yeah, let's go ahead and write our two statements. So 2x minus 1 is less than 2, or 2x minus 1 is greater than a negative 2. Again, go solve those. You'll get 2x is less than 1, x is less than 1/2. Over here, we're going to get 2x is greater than a negative 1, so x is greater than a negative 1/2. That worked out nicely. Somehow I think I've made a mistake somewhere. Negative 1. I did. Hopefully you caught that mistake instead of yelling at me in the computer, right? Wait, that's a 3. That's a 3. Sorry. For me, it's early in the morning while I'm taping this. So we have x is less than 3/2 and x is greater than a negative 1. Off to the number line. And the main reason you do the number line is so that you can interpret those answers. We know that we need to open circles again because of the inequalities. They're exclusive. You do not include the endpoints. This is wanting numbers that are bigger than negative 1/2. That would be to the right. And the minute I know that, this one being less than 3/2 is going to be to the left. So we're trapped between the two. What we're really doing is we're looking for the overlap. This one would be going this direction. This one's going this direction. And the overlap occurs between the two. That's what we're looking for. We're going from negative 1/2 to 3/2. And here's our answer. These are the numbers that satisfy both inequalities. One more. So example 9. Example 9 says we have the absolute value of negative x minus 2, and that's going to be greater than or equal to 1. So for the first time, we see a negative on the inside of the absolute value bar. Yeah, so what? The process is the same. It's not going to change anything. So our first statement is negative x minus 2 greater than or equal to 1. Our second statement is negative x minus 2 less than or equal to a negative 1. Again, what I hope you're doing is stopping, solving it on your own, and then starting the video back up so you can check and make sure that you did it correctly without me. First thing we'll do is move our 2, so that's going to give me negative x is greater than or equal to 3. And then we have to divide out that negative 1, remembering that when we divide by a negative, the inequality gets flipped, so less than or equal to negative. When we go to solve the other one, we'll move the 2. So negative x is less than or equal to adding 2 is going to give me a positive 1. Again, dividing out a negative is going to flip the inequality, giving me x is greater than or equal to negative 1. To interpret that, we're going to come in and go to our number line, our handy number line. Negative 3 is smaller, negative 1 is larger. Both this time we're going to be closed circles. Excuse me. Okay, this inequality statement is saying you need numbers that are smaller than negative 3, which would be to the left. This one is saying you need numbers larger than negative 1, which is to the right. So we're going to go from negative infinity to negative 3 with a bracket, and from negative 1 to infinity with a bracket on the negative 1. Again, we'll put the union symbol between the two. And there's your second one where they point away from each other.